Okay. Let's see what we got. Count the number of substrings with dominant ones, medium. Right. Pretty good about today. You're given a binary string S, return the number of substrings with dominant ones. Dominant ones. This string has dominant ones if the number of ones in the string is greater than or equal to the square of the number of zeros in the string. The number of substrings with dominant ones. The string has dominant ones if the number of ones is greater than or equal to the square of the number of zeros. So if there's a substring of just one would work, right? Okay, so one by itself, I guess a substring of one is equivalent here. So 1, 1, 1, that's 2. 0, 1 is 3. 0, 1, 1 is 4. What other substrings are there? Unless you count the two ones as being separate substrings. Okay, yeah, they do count the two ones as separate substrings. Interesting that they would count that way. Oh, it makes it a little easier, maybe. Okay, here, everything that's just one by itself be count. So there's 4. There are singleton ones. There's 1 that's a duplicate 1, 2 ones, so that's 5, 6, 7, 8. That's as far as it goes. 9, 10, 11, 12, 13, 14, 15. Somewhere I missed one. Okay, I think this is a sliding window deal. You open the window. You open the window to the right as far as you can, going from stationary left, or you I was counting based on sliding the window outwards to the right. So 1, 2, 3, 4. But then that would be n squared, I think. I think there should be sliding windows. You generally want to make this O of n time complexity. So 1, 2, 1, 2, 3, 4. That's not going to work either, huh? Because in theory, if you stick with the stationary left side of the window, like there could be a 0 here, and there could be like, let's say, 40 more ones. At which point, even though you don't include the substring that ends at the 0, you somehow do include longer substrings that extend past that 0. Interesting. Okay, this is not it. Not it. Can I do it from the left side, or can I do it from the right side? So here, 1. Here, 2. From here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, still counted 15 again. Oh, 16. And then that works. So, okay, let's see what the parameters here are. 10 to the 4th, 4 times 10 to the 4th. Length, 4 times 10 to the 4th. If I do an n squared there, then that'd be 16 times 10 to the 8th, which is 1.6 billion. Yeah, it's not going to be n squared. It's going to be n log n, or possibly O of n. Ideally O of n. Ideally O of n. Alright, so what if I at each index somehow kept track of the number of ones to the left of that index inclusive? So would that be helpful? Ones to the left of that index inclusive for each index. So number of dominant ones. So that might be just harder for me to interpret than the reverse of that. So for each index, the number of ones past that index inclusive. Let's do that. I think I just want to see what the array looks like. Later ones is going to be that. I'll do the total ones is going to be the string count 1. And I want to do for every index in range n, where n is the length of the string. I think I'll do something like later ones append the total currently, and then the total if the value of this index is 1, total ones decrements. Okay. So at the first index, there's 4 ones. Second index, there's 3 later ones, 3 later ones, 2 later ones, 1 later one, 1 later one. Not quite what I need. Is it? Is it? So if I try to consider being at index 0, so index 0 is the left of my dominant substrings. The ending of my substring needs to be such that the amount of ones within the substring is greater than or equal to the number of zeros squared. How to quickly identify that based on this array, maybe? So I'm at this index, there's 4 ones to the left. The difference between the value of ones here and the values of ones at the later indices would be the number of ones between this index and the later index. The later index being non-inclusive of the substring. So 4 to 3 is 1, 1, so there's 1 in that substring. 4 to 3 is 1, 1, so there's 1 in that substring. 4 to 2 is 2, so there's 2. 4 to 1 is 3, so there's 3. 4 to 1 is 3. Why is this 9? Sure. There should be one more here, I think. Because it's not inclusive of the index, so I think I probably need to have 0. I need to append a 0 at the very end of later ones, just to keep it straight. So the substrings from starting with the first or 0 index inclusive to the second index not inclusive, there's 1, 1, 1, 1, 2 ones, 3 ones, 3 ones, 4 ones. And then somehow I have to consider the number of zeros implied with that based on the length of the string, subtracting the number of ones. Then I also need to consider that the number of zeros need to be squared, being greater than the number of ones. Number of zeros being squared being less than the number of ones. That doesn't seem like a very fast task. It doesn't. Does it seem like a fast task? Do-do-do-do. The number of zeros. If I go from every 0 oh man. Dominant. Indeed. Dominant. 0, 0. You need 4 zeros or 4 ones. 0, 0, 0. You need 9 ones. All the substrings that have a certain number of ones. Seems like it should be a prefix, so okay, maybe I should just reverse this. I guess I'll just make this prior ones starting with 0. Total ones is that. I guess I don't need the total if I go the reverse direction. I guess this should be if s at index equals 1, then total increments. Your total starts with 0, and then I guess this is basically a prefix sum. So prefix append total. Maybe I should just append a 0 at the very end still. Prefix append 0 at the very end. This is just going to use -1 as the backside indexing of the array in Python. Oh, I forgot to print it. It should just be the same thing but the other direction. So it should be like 1, 1, 2, 3, 4, 2, 3, 3, 4. Okay. So for any given index where I know the number of ones, I would need to know the number of prior interesting, because the values themselves, I need to know the difference. I need to know the difference between values. Okay, so my array was, or my string was 1 1 or 1 0 1 1 0 1. Prefix is equal to this, which is the at each index number of ones from start to that index, and then dummy end. So the difference, the prefix of say m minus the prefix n is equal to the number of ones between number ones in substring from n to m. That'd be inclusive of m, exclusive of n. And then the number of zeros would mean, well, I first need to know the length of the substring is equal to m minus n, and then the number of zeros is equal to the length of the substring minus the number of ones, and then there's a lot of calculations. So let's say I'm at the last index 4. There's 1 1, length 1 obviously works. 1 1, length 2, that works as well. 2 ones, length 3, that works. Hmm. Number of substrings. So from this index, the number of prior indices. The values themselves are constantly adjusting. Each additional step would have a different length. Thinking about this wrong. Would it be binary search? Can I guess the number of dominant substrings and search that? Can I guess the number of dominant search substrings? And do a single pass to determine whether or not that number of dominant substrings is possible. I don't think so. I don't think so. Can I do some sort of logic where I can deduce that if something doesn't work, then I shouldn't consider something else? Like if there's no substring that ends at a certain index, then it doesn't work for a prior index or a later index. I don't think that works either. Well, yeah. I don't know if that works either. The number of ones between two indices for each possible substring, the number of ones within those. The number of ones within those. What if I did something where I search through the zeros? What if I did something where I search through the zeros? Seems a little inefficient, but like for each ending index, I look at the prior index of a 0 from that, and then, so let's say you have something like, the string is 1 1 0 1 1 1 1. So, and let's say you're dealing with this index right here as the ending of a possible dominant substring. if I look at this and go to the first prior 0, any substring that is between them would count, right? Because that would mean that you're dealing with ones, like 1, 1, 2, 1, 3 ones, 4, however many. So all these would be, so if I end with this thing, that's 1, 2, 3, 4. Do I include the 0? I don't think I include the 0. So from this index, go to the prior 0. That'll be all the 1 substrings. And then whatever that amount is, I would if this is 0 is not the same index as this thing, then I would also include it. So 0 to the non-inclusive of the last index would be another possible subset. Because if 0, I guess if it ends with 0, then maybe, no, I do need to consider if it ends in 0. So from this 0, okay, let's assume that starts with 1. So that means that all substrings going to the first 0 is possible, or the most recent 0 is possible. So 1, 2, 3, 4, 5. And then from there, you kind of do a process where you go to the next prior 0. So let's go like 0 here. Because then that would just mean that everything there would have 1, 0 within it. I guess if you start with 1, then you can immediately go to the 0. You can go to the second 0. Because then everything here works. But not, you can't go to this, you can't include this 0. Okay, and then what? And then you'd go to the next 0 before that. That'd make it 3 zeros. And you would take the difference between that and something that is at least 4 length, no, at least 6 length. At least 6 length, so that you have, at least the length of where this is compared to here, up to here, as long as it has at least 6 length. Because that would mean that there's 2 zeros and 4 ones, or at least 4 ones. It's disgusting. So you have to do some sort of manual thing there. That is disgusting. Go from the prior 2. Need 4 ones. Alright, let's consider it here. It's possible this is dynamic programming. either dynamic programming, which would be, I mean, dynamic programming might be n squared. I think this is too big for it to be dynamic programming. Other than that, then it'd be sliding window. How to slide the window. I guess it could be like a monotonic stack. Could it be heap? Heaps doesn't do well here just because the things themselves are being modified each time. The number of implied ones. Number of implied ones. Prefix ones. I guess I could do prefix ones and prefix zeros to, yeah, I guess I could just do prefix ones and prefix zeros. Is that going to be that big a difference? I guess that just more quickly resolves. Prefix ones and prefix zeros. So any part n index where the current index is m, it's more of a direct calculation for how many ones and zeros are between n and m. How many ones and zeros between n and m. And then if I okay, let's go ahead and just make the prefix ones or prefix zeros. Yeah. Prefix 0, append number of the index plus 1 minus the total. Okay. So index 1, or the first index there's 0, zeros, 1, 0, 2, 1, 0, 1, 0, 2, 0, 2, 0. Okay. Sure, I think that's right. So if I'm at this index, where there's 4 ones to start, subtracting 1, there's 1, 1, 0, zeros. The number four minus 3 is 1, 4 minus 2 is 0, 4 minus 3 is 1, 2 minus 1 is 1. I might just be thinking about this wrong or visualizing it wrong. So for any given starting index, there's going to be some sort of almost random walk from 0. If I visualize it as, for a starting index, as kind of the left side of the dominant substring, if I extend out the window to the right, I visualize it as kind of a graph of the number of what am I graphing? Graphing of the difference, graphing of, wouldn't necessarily be the difference of ones and zeros. Graphing of the number of ones. Graph of the number of ones. As I extend out to the right, the number of ones needs to be above a certain threshold, where the threshold is what? Yeah, it's not a very smooth graph. Extend out to the right, I can graph the number of ones. And graph the number of ones. Which would go, I'm thinking of a random walk in terms of like the number of ones above the number of zeros. So it'd be like, that random walk would be going incrementally 1 up or 1 down from the previous value. So it'd be starting at 0, it can go up to +1, +2, down to +1, down to 0. Goes like 1, 1, 0, 0. Then where that doesn't necessarily map to any, it's not like there's a certain threshold it needs to be at to guarantee that there's a dominant number of ones. Each 0 needs to be accompanied by some increasing amount of ones. The first 0 needs 1, 1. The second 0 needs 4 ones total. So it'd be 0, 0, and then 0, 0, and then 4. And then if there was 3 zeros, it would need to be 9. So if I have some string that starts with zeros, right? Say a bunch of zeros, followed by a massive number of ones. So I see this 0, that's just not going to work with something this short. And then I see 2 zeros, then I would immediately go to this index 6 to see if by that point there had been 4 ones, which there isn't. So go to 3 zeros. So 3 zeros means, because it takes 3 here, so 3 zeros means I need to go to like the 9th index, or 3 plus 9, so it needs to be 12th index in order for it to be, in order for it to have a chance of having enough ones, and then that doesn't work. And then 4 zeros needs to go to this 4 plus 16, so 20th spot to see if there's enough. This is too slow. It's too gosh dang slow. Like, we're dealing with 10 to the 4th, so that's like each index takes actually this is a square number, That'd be 2 times 10 to the second. 2 times 10 to the second. The second is 200 operations. So 200 operations, what are 200 operations times 4 times 10 to the 4th? $8 million. Is it 8 million? Yeah, 10 to the 8th. 2 times 10 to, that should be 8 times 10 to the 6th. Yeah, okay. 8 million operations. It's probably going to be shorter. Well, no, that's just the upper bound, I think. So for each index, iterate kind of like that, which would take 200 operations at most, I guess. Okay, I probably need to refine that though. So for the starting index, go to the next 0, and then go to all the strings up to that 0. So let's say it was something like this. So if I take the start index here, up to the first 0 is that, and then if I include the 0, then all the substrings that need to have 1, 1 at least. So from this index up to the second 0, minimum 2, where 2 is 1 plus 1. So start index plus 2 up to the index of the second 0. And the difference there is going to be the number of possible substrings that include 1, 0, and at least 1, 1. And then the next one would be 2 1s or 2 zeros. So it'd be minimum start index plus 6. Up to where the third 0 is. Oh, it's disgusting. It's so disgusting. Hmm. I'd do something where I consider the incremental cost of adding a 0. Like if I want to include this next 0, then I need to include another 1. So it needs to be this one, 1, 0, needs to be at least 1. Everything after that's fine. Then if I include that 0, it's just not going to work in terms of the 0. I don't know how many prior 0s there are. Keep track of the indices of where the 0s are. Just keep track of the indices where the 0s are, then adding another 0. Here's a square number. Yeah, I'm skipping over a fair amount of indices during this process, maybe. Maybe 200 possible indices where the 0s are, because we have more than 200 zeros, and therefore it'd be past the end of the string. Oh gosh. there a faster way? Oh. Okay. Alright, time to get on my horse and actually do this. Try to get a solution, even if it's very inefficient. 0 spots for every index in range n. Let's go if this if value at this index is equal to 0, 0 spots, we'll append this index. And then I think I still need prefix. Probably need prefix, probably need 20 prefix. Actually don't, right? I'm manually counting based on differences everywhere. Okay. If I can get like one of it down correctly, then it should work out. Okay. So I'm going to consider this the start index. Okay, I'm considering basically some example like this. So this would be something like answers equals 0. For let's say the length, let's say the num zeros is gonna go for in range I guess length here like the total 0 is going to be the length of 0 spots, so the number zeros will be up to the total, and I'll break at some point. So if there's 0 zeros, then what I'm doing would be going from this index inclusive to where the first 0 is exclusive. So it should be, the count of these should be, this should be modified later on, but something like 0 spots of this num zeros minus the current index being start. So there's 0 zeros, then this would, let's just do 2, oops, need to add the test case. One, 0, 4 ones, 5, 6 zeros, 1, 2, 3, 4, 5, 6, a bunch of ones. Whoops, well, ending quote. Okay. So my zeros are at those indices. So the count, that would work for num zeros being, that would work for num zeros being 0. 1 minus 0 is 1. So there's one thing there. And then it needs to update. The logic here is incorrect. The count of the valid stuff should be from here to it needs to be, so the earliest ending should be the start index, the minimum, the maximum, min or max, one of those two. Start index plus the number of zeros squared plus the number of zeros squared times 2, because the number of zeros squared is the number of zeros. The number of zeros squared is the least number of ones. Number of zeros squared plus number of zeros. Yeah. Yeah. Number of zeros squared is the least number of ones. And then you have the number of zeros. So if this is like 1, if there was 1 0 in it, and you need to have at least 2 things. So the earliest ending has to be 2 indices after this. I think that's right. And then I have to consider whether or not going to that index actually has enough. Going from here to that index, has enough. So it'd be from that index to where the second or the next 0 resides. Right? Going from that index to where the next 0 resides. The difference there should be kind of the possible actual endings. So the earliest end so this should be, so in theory it could early end at this index. Earliest ending is that, and it could be at most, it can't be farther than, so the minimum between this and where the next 0 is. Where the next 0 is going to be num zeros or 0 spots at num zeros plus 1. The minimum there. Yeah, so here earliest ending is going to be here. All the way to here. I guess this is inclusive of that spot, or exclusive. I think this might be exclusive spot, so maybe it should be start plus all that plus 1. Start plus all that plus 1. Up to the 0 spots at the next number of zeros. So that's the earliest. Yeah, I think that's the earliest end. And the actual count is going to be based on the difference between that. No, the count is based on the difference between this and where the next 0 is. Zero spots. Zero spots at num zeros plus 1. Minus the earliest end here. Okay, so starting index is 0, num zeros is 0, num zeros is 0. I think I might be confusing num zeros plus 1 with num zeros. Maybe this should be just that, because the index where 1, 0 appears is where the first 0 is. So the minimum of start plus all this jazz is currently 1. 0 spots for the first 0 is at 1. So early end is going to be 1. And so this should be 1. I feel like this should be plus 1 minus the early end, so that gets me 1. Yeah, okay, let's try with a couple more ones in front. To do okay. In theory, if I start out at the first or 0 index, there should be like three dominant substrings with 0 zeros. 3 dominant substrings with 0 zeros. So num zeros is 0. Start is 0 plus a bunch of zeros, so early end is 1. So the earliest ending needs to be at 1, right? In order to have at least 1, 1. And then minimum between that and the spot of where the first 0 is, which is 3. So that's going to give me 1. And the count be 3 plus 1, which is 4, minus 1, which is 3. That gives me 3 substrings that have 0 zeros, 1 1, starting at index 0. Okay, then moving there, num0 is now 1. The earliest start, if you have 1 1, would mean that it needs to have 2 needs to be at least 2 away from the start. Needs to be 2 away from the start, but then 0 spots. Min or maximum? So I can't actually. If I do 2 here, then I've already counted that. I already counted that. Needs to be at least the 0 spots at num zeros, or needs to be at least at the num 0 spots at num 0 spots at num zeros minus 1, or the earliest end. Earliest end. Maybe that should be called earliest start. So how am I thinking about this? Start is, this is the earliest end. No, this is the earliest ending. Yeah, earliest ending. The earliest ending needs to be at least the later of the two. No. Work later of the two. Earliest ending can't be. Maybe I need to actually have an extra 0 spots at 0. Maybe I need 0 spots at 0. Or 0 spots at -1 to be 0. Earliest ending, the minimum, or is maximum. 0 spots at num zeros minus 1. I think it's always going to be +1. It's going to be start plus that plus 1. Zero. And then out would be okay. Does that work still? So this is like having a 0 here. So the maximum there would be 1. When num0 is 0, early end is going to be 1. And 3 plus 1, 4 minus 1 is 3. And then if I include 1, 0, num0 is 1. The earliest ending is going to be start plus 2, so in theory ending at index 2, and at index 2 start plus 1 plus 1 plus 1, start ending at 3, 0, 1, 2, 3. 0 plus 1 plus 1. Needs to be at least 1. Should be 1 comma start plus num zeros. No, start plus 1. Number zeros. Number zeros plus the number 0 squared. 1 plus 1. So it needs to be at least 2 length. Can't be just 1 length. This is start plus 0 plus 0. Let's be start plus 1. And num zeros is 0. 0 plus 0 squared. The maximum between that and I guess that's fine. And where the 0 spots is, I guess in that case it's still exclusive. Okay, so I think that might still be fine. No, that means the max is just going to be, this is going to be 0. 0 spots at -1 is 0. And this is also going to be 0, so early end is going to be 0. Then that'd be 4 plus 1 plus 3 plus 1, 4, 4 minus 2 zeros. So that doesn't quite work. Inclusive or exclusive? Early end should be exclusive if I'm using 0 spots. Start plus the length. So start plus the length is normally good enough. I guess I could go from num zeros starting with the 1 rather than with the 0. And just do something like answer plus answer plus the difference between this index and the next 0. Num zeros start. I guess I should have a z index given this, because the z index needs to be where it iterates from. or z offset. Because this is not always going to have starting with 0 at the very start. It needs to be something like if the value at this index is equal to 0, then z offset increments. And then something like for every num zeros in range of z offset to total, something like that. It doesn't work. In range of total 0 minus the offset, and then I have to index using the offset. Or I could use a stack or something. There should be 3. So it should be counting 3, and then it should go from start range n. Answer increments by what? Answer increments from here to the next. From here to the next. Z. Next 0. So 0 spots at z offset. Minus start. All count of substrings with 1 and no zeros. So the start is 0, the next thing is 3, and that gives me 3. Start is 1, next thing is 3, that gives me 2. Start is 2, next thing is 3, that gives me 1. Okay. Can I do this logic again? So for every num zeros, maybe I can do num zeros from 1 onwards. Because this is dealing with 0 zeros. Okay, so if I deal with 1 0, earliest ending has to be at least this index, and it has to be at least oh my gosh, min, is it the maximum? Yeah, I think its maximum is at least 5, 2 and 5, 5, at least 5, 10 and 5. That'd be 10. So it should be at least the 0 spots at the num zeros plus the z offset. The offset 0. So that'd be 0 plus 0. No, that'd be 1 plus. That should be minus 1. So the earliest ending is where that 0 is. So that would be the number of zeros, which is 1, plus the offset currently, which is 0, minus 1, which is 0. Z spots of 0, which is 3. And the start plus the number of zeros squared plus the number of zeros, which means it has to be at least 2 length. Can't be shorter than 2 length, right? So if this 0 appeared like here, well, if the 0 was right in front, then the earliest start can only be 2 away and not at the index of 0. So earliest start would here be 2. 2 being the earliest ending. Is it inclusive? 2 has to be inclusive, I think. So 0, 1. So it's not currently inclusive. So is it start plus num 0 squared plus num 0 minus 1? So I want to have inclusive of the early end. Earliest ending inclusive. Otherwise I can have num 0 spots, num 0 is offset minus 1 plus 1 here. And then I wouldn't have it inclusive. I want to include. Do I want to include? So I think I want include here if this was a 0 later on. I think this is fine. So the earliest ending is here because it's between 2 and 3, which is here or here. Right? What if it was like that? So the index of the ending here is going to be 1. index of the ending here is going to be 1. Earliest ending is going to calculate 2. In theory, I want it to be 1. Maybe it is num zeros minus 1. It includes that index. And then the latest end is going to be, the latest ending is going to be where the next thing is, where the next zero is. Zero spots at num zeros plus offset. So that'd be 8. And then something like answer plus equals the difference between that. And if this needs to be at least 0. So that'd be 8 minus 3, which is 5. Is that right? Originally it was like that. So that's index 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 minus 3 means that I have 5 things there. Not inclusive of that. Okay, and then num zeros becomes 2. So 2 means that the 0 spots needs to be from start plus 6 to start plus 6 minus 1 is the start plus 5, or num zeros 2 plus 0 minus 1, so from 8, 5 to 8. So it needs to be at least here. Alright, start plus 6 minus 1 is 5. 0, 1, 2, 3, 4, 5. So yeah, that means there's at least 6 characters. Or this, so it needs to, so it'd be 8 here. And then 8 goes to the next one, which is 9. Okay, that doesn't work. It'd be 9 minus 8, which is going to give me 1, which is incorrect. The latest ending is latest ending doesn't work. It's 9. So maybe it should be 9 minus 8 is going to give me 1. Wait. Here, this should be the maximum. Oh, okay, this is actually bigger, right? Yeah, it's going to be bigger than 9. And then 9 minus that bigger number is going to be negative. And then, This should be maximum. Negative and 0 should give me 0. Okay. Then I think I need to prevent this from going out of bounds. Total number of zeros minus the offset. I know this is going to go out of bounds. Just need it. No, this is going to go out of bounds. I wonder if I need to actually append a 0 after going total 0. Z offset, 0 offset, it needs to be used there. Output 0, I think I returned -5. Oh boy. Answer's definitely, oh, I see. Well, yeah, this is definitely causing it. 0 spots of Z offset minus start. When would this, this is when it's 0 maybe? 0 minus, I guess if this is, when does this thing stop? When should this thing stop? Every, okay, this thing should stop when the earliest end is past the length of the string. If early end is greater than n, break here. That doesn't quite solve it, but that should make it faster. So index is here, Z offset 0, Z offset 0, Z offset's 1. Index is 3. 0 spots of Z offset is I guess maybe if this thing goes to the last Z and everything past that is no longer there, then I can just do a calculation from there. So if Z offset is equal to Z total is equal to total's number of zeros, then I'm at the last 0. So like index 13, and then I just do something that is, just do a final calculation. That should be like n squared divided by 2. The remaining is going to be n minus this offset. Answer plus equals remain plus 1 times remain divided by 2. Something like that. something like that. Probably off by 1 maybe. Probably be more careful in this calculation. So let's go with a test case of all ones. Truly the greatest test case. Okay, so I got that wrong. So the 0 spots here should be 0. 0 spot should be just 0. Maybe it needs to be at the very start, actually, because this could be done before this. Should be done before that. Six and 10. Okay, it was originally the +1. Okay, so those kind of work. And these don't. These definitely do not. Oh boy. Okay, so let's consider what's going on that might be incorrect. Okay, so let's go print out start and the new answer. Okay, so 0. So starting at index 0, there's 2 that works. 1, 2, 3, 4. There should be 4. No, there should be 1, 2, 3, 4, 5, 6, really. Oh boy. Starting at index 0. Starting at index 0, there's 1, 2. There should be 1, 2, 3, 4. Guess that doesn't work. 5. There should be 5. Okay, so answer increments by print trivial let's say start index answer. Yes, maybe I can do 0 spots as the offset minus start. So yeah, there's trivially 1 here, 0 here, 2 here, 1 here, and one last one. Eeks. There's 1, there should be 2, there should be 1, and there should be another 1 here. Why is it indexing through only 4? Guess it broke. It must have done a break at this. Okay, the last one was just based on that. Okay. Okay. So the trivial case is fine. 0, 2. So that means it must have incremented just once here. The earliest end is the maximum. Early end is greater than n. Break. The num zeros. The latest end is num zeros plus the offset. Those are the indices. Okay. No, the num zeros in the start. Latest end, late end. Okay, so start is 0, 1, 0, 3, and 4. So if it starts at 0, earliest end is 3. Because that's where the second 0 is, and the latest end is 4. That doesn't seem right. 4. Latest end is oh boy, bother. The offset is wrong again. So start plus 1 minus 1 is 2. Here, 1, 2, 3, 4. 0, 1. Start num zeros. There's 1, 0. 1, 0. Num zeros, which is 1. Plus offset, which is 0. Minus 1. that be -2? -2 because I want to go back 1. Then this thing needs to be -1 then. Okay. This thing still works. Okay. So is it kind of close to being right? Not really. Not really. Actually, maybe I should do this one. 0, 0. So there should be 4 here. So this should start with, the start index should be 0, 1, 2, 2. And there should be calculating 2 there. We only calculated 1. 2, there's no trivial. 2, there's no trivial. So then that should mean that it doesn't do early end here. It does the break there. No, it doesn't do the break there actually. So it does do this. Reveal 2, 0. So it prints out here. Probably doesn't do this at all. Print 0 spots. I guess it's gonna do 0, 1, 2. Okay. So the total is gonna be 3. Offset should be 2. So it should be 1. 3 minus 2 is 1. So 1 to 1, so it doesn't do it at all. So maybe this should be +1 here. This might go out of bounds. Hmm. 0, 1, 2. Zero, 0. Okay, so it just went. So it does do it now. That last pass, but it calculates incorrectly. Yeah. 2, 1, 1, 2. 2, 1, 1, 2. start is index 2. What am I looking at? Start is index 2. Earliest num0 is 1. Earliest ending is 2. Latest ending is 3. Earliest ending is 1. Latest ending is 2. That doesn't seem right. Earliest ending should be early ending is 1, latest ending is 2. Why would early end be 1? 0 spots for num0 is minus 2. Maybe I need to go back to my previous thing. Okay. Well, so this thing works now. Earliest ending is 2, latest ending is 0, so it adds. Why would the latest ending be 0? So somehow added 2. Trivial 0, trivial 0, trivial 0. Should have added 2, but had to add 2 based on those values. Latest ending minus earliest ending. Latest ending minus earliest ending. Latest end. So it didn't do that based on the logic there. So what did it do based off of this thing? Zero, one, two. No, on the pass where it prints out start and answer, the start was index 2, the answer was 2. Did it do it based on this thing? This was trivial. This thing was 0 right there. Trivial 2, 0. So what did it do based off of? Didn't increase the answer. Oh. Did it based on the 1. Oh boy, that's not right. No, it did it based off of when it was index 0. When it was index 0. That's definitely not right. Well, even at index 1 it was wrong. When it's 0, it's increasing to 1. When it was 0, it's increasing to 1. Okay, so num zeros. All right. Yeah, this is